FlexLinks are a Cisco proprietary layer 2 availability mechanism. And what do? Well, first and foremost, they turn off spanning tree protocol. That's right, I said it. They turn off spanning tree protocol. So how does this prevent a loop from occurring within our topology? Let's say we have this physical loop. Well, when FlexLinks are enabled on the interfaces, let's say fast Ethernet 0/1 and fast Ethernet 0/2 within this topology, this one is going to be the active link, actively forwarding traffic, and this link's in the standby state. So it's not going to be forwarding traffic at all. That's how the loop is prevented while spanning tree protocol is turned off. With spanning tree protocol, we could load balance on both links on a VLAN by VLAN basis. Well, with FlexLinks, you don't have that ability. It is all or none, active and standby. But failover can be as low as 50 milliseconds, as we see here. And why is failover so quick? Well, we have this active link on the left-hand side, and we have a standby link on the right-hand side. If all of a sudden this active link fails, the standby link can go active and continue to forward traffic within our topology. In this case, our two switches that we see at the distribution layer, B and C, they are not aware at all of FlexLinks. FlexLinks are only configured down here at the access layer where we have the links going up to the two distribution layer switches. So how can we configure this? Let's examine this on ASW1 within our topology. We will go into global configuration mode and then go to interface gigabit Ethernet 0/1. We want gigabit Ethernet 0/1 to be the active link. So all traffic coming from PC1 and PC2 are going to flow up from ASW1 towards DSW1. And if and only if this link fails, will the standby link between ASW1 and DSW2 go active. So in order to configure this, we have to go to the active interface as we see right here. So gigabit 0/1, and we are going to type in switch port backup. And then we're going to specify the interface. What is the backup interface to gigabit 0/1? It is gigabit Ethernet 0/2. In addition to that, if a failure occurs and then the problem is solved and gigabit 0/1 goes back up, we want to make sure that it becomes the active link again. So we have to turn on preemption. We want gigabit 0/1 to be the preferred. We want it to be the preferred link. So we want to make sure that if it comes back up, that it becomes the active link again. So preemption mode is going to be forced. So the active interface is preferred. All right. Notice spanning tree protocol has just been disabled. All VLANs have been deleted in this case. So if we want to identify our interfaces, let's type in show interfaces backup. Show interface switch port backup. And we can see from this output that the switch backup interface pairs for our FlexLinks. The active interface is gig 01. The backup interface is gig 02. Active is up. Backup is standby. Let's cause a failure. Let's go to DSW1. And on DSW1, global configuration mode, interface gigabit 1/0/1. Let's shut down this interface. When we shut down this interface, we should recognize, or ASW1 should recognize, the interface is down, and now gigabit 0/2 should be active, or not active, pardon me, it should be forwarding. So now the backup should no longer be in standby, the backup should be up. Let's take a look at that. Show interface switch port backup, and we can see right here, backup is up. So now we're successfully sending traffic up gigabit Ethernet 0/2. Let's examine what happens when a FlexLink failure occurs. What I'm referring to here is the active link that is currently forwarding traffic goes down. As a result, the standby link has to come up. So in this example right now on switch A, this is where we have our FlexLinks configured. Fast Ethernet 0/1 and Fast Ethernet 0/2. As you can see, Fast Ethernet 0/2 is currently the standby link, and Fast Ethernet 0/1 is the active link. So all of a sudden, the failure is detected. So the failure is detected because this link goes down. The interface goes down, the cable's unplugged. Something happens which causes the active link to fail. When this occurs, all of the dynamically learned MAC addresses on Fast Ethernet 0/1 have to be moved over in the MAC address table to Fast Ethernet 0/2. So the process does that automatically behind the scenes. And the reason why is very simple to understand. This server right now, its MAC address was associated with this interface right here. Right down here. That's what it was associated with. So it has to be moved over to the standby interface to Fast Ethernet 0/2 in the MAC address table. After that is accomplished, then the link goes up. So the link goes up. Let's draw that in. So the link goes up. And now that the link goes up, it's forwarding traffic. However, right now, the MAC addresses of our PCs, as an example, that are connected downstream from switch A are not learned properly amongst the switches. For example, this PC's MAC address is associated with this interface right now from previous communications. So switch A, what it does is it transmits dummy multicast packets on this new active interface. So whatever MAC addresses it learned from downstream devices, it will transmit upstream, up this interface. So switch D learns it, and then switch C learns it. And switch B learns it inbound on this interface. So behind the scenes with the FlexLinks, there's a lot going on to make sure that all the MAC address tables get updated when that transition occurs from the active link to the standby link.